Hello and welcome to this Edexcel Further Maths Statistics 1 video looking at the probability generating function for the sum of random variables. So at the top of this slide we have the definition of the probability generating function for a discrete random variable x, and you can see that this suffix here denotes that the generating function g of t is for that random variable x. We're going to consider in this video the sum of two independent discrete random variables, and it's worth noting that the probability generating function for the random variable y would be written gy of t, and that's the expected value of t to the y, and also the generating function for the sum of those two independent random variables, x plus y, would be the expected value of t to the power x plus y. And if we just consider the generating function for the sum of our two random variables as e of t to the x plus y, we can write that using the rules of indices as e, or the expected value of t to the x multiplied by t to the y, and because x and y are independent, t to the x and t to the y are also independent, therefore we can write that as the expected value of t to the x multiplied by the expected value of t to the y. And of course, if we know the probability generating function for x plus y is et to the x multiplied by et to the y, the product of the two expected values, it's quite clear to see that the generating function for the sum of those two independent random variables is simply the product of the two individual generating functions. Looking at that in the context of two random variables that are Poisson, we have x that is Poisson with parameter lambda 1, and y, an independent discrete random variable, Poisson with parameter lambda 2. And on this line here we have, from the definitions given to you in the formula book, the generating function for x and the generating function for y, two Poisson variables. So if we now consider the generating function for x plus y, this is the product of the two individual generating functions, and using the rules of indices, that would give us e to the lambda 1 t minus 1 plus lambda 2 t minus 1, and clearly factorising there, that would be e to the lambda 1 plus lambda 2 multiplied by t minus 1. And this is clearly the generating function for a Poisson random variable with parameter lambda 1 plus lambda 2. And therefore the result is obtained that you know already, that if x and y are independent Poisson variables, then their sum will also be a Poisson variable with parameter the sum of the two individual parameters. And you should have used this result when you did your work on the Poisson distribution. So considering an example here, we're going to revisit the example of the spinner that we looked at in the previous videos, and you should recall the generating function for the spinner where each outcome has the probability of 1/4. We're introducing another random variable that we're calling x, and that is the number of heads obtained from flipping two coins. And I think it's fairly clear that the outcomes possible for the number of heads would be either 0, 1 or 2, with probabilities a quarter, 2/4, a quarter. And so we can obtain the generating function for the random variable x for the coins as a quarter multiplied by t to the 0, 2/4 multiplied by t to the 1, and 1/4 multiplied by t squared. And so for the game, which is looking at a score as the sum of those two individual independent random variables, our generating function would simply be the product of the generating function for x and the generating function for y. And this is written out for you on this line, where the quarters are multiplied together to give you 1/16 at the front of the expression, and then we have the two functions in terms of t multiplied together, which then gives us our generating function for x plus y. And it may be a useful exercise to look at the probabilities of the outcomes for x and for y, and to produce a table and just check that the probability of scoring 0, for example, would be 1/16, the probability of scoring a total of 1 would be 3/16, and so on. And that concludes this section of videos on probability generating functions.